right, and let's go back. I do know that I've got some questions from y'all, but I'm waiting to go over them because I want to finish a little bit of chapter 3 so y'all can start working on the homework. So y'all just bear with me on the questions right now, okay? All right, what do I think? Y'all help me out. Look at your outline. I think we go to 3.6 or 3.5. Which one is it? Do we skip any?
3.
We skip 3? Okay, remind me of that when what is it? Yeah, dispersions. We don't do dispersions. All right, I think I'm pretty much going to we're going to whiteboard this for right now because I do better not teaching with the book on this section because this is math. So, statistics. What is statistics? Well, most of y'all know because y'all had it. Statistics, there's 2 types of statistics. There is capital S and lowercase s. Uppercase is collecting, tallying, interpreting, that's one of those words I always have a hard time spelling. I hope interpreting, don't look right, but anyway. Interpreting and, calculating also is in there. Calculating is before interpreting. All right, that's basically data. When you go out and do surveys, when you go out and count cars, when you watch a rat in a maze 15 times, that's all collecting data. You tally it, you record it, then you take it in, you calculate it, and then you tell somebody what it means. Now, the whole point of statistics is to get the data so you can run it through the probability so you can predict. All right? A lot of people think that statistics sits by itself and probability sits by itself. No, they work together. Okay? Later on, we're going to take statistics and we're going to take probability and merge it and come out with a 96 or a 97 or a 98 confidence interval, which says I'm 98% confident that the data that I've obtained, calculated, and interpreted is a good representation of the blah, blah, blah of the population. Okay? That's what it means. So, with that being said, what is little s statistics? That is I like to call it the variable for sample calculation. Whereas parameter is the variable for the population calculation. Okay? Parameter is usually in Greek letters. And statistics is usually in regular letters. Now, why do you need to know this? You don't need to know it to pass this class. You need to know it so you don't show your ignorance in a meeting in the future. Okay? If you're in a presentation, whether you're an employee or a student or whatever the case may be, and you're sitting in this presentation and the presenter goes, well, we know that mu is equal to 28, where sigma is equal to, mu is equal to 28, where x bar is equal to 26. Then, without raising your hand and sounding ignorant, you know that the population mean is 28 and the sample mean is 26. How do you know that? Well, mu is a Greek letter. So that is a population parameter or a population variable. I like to call it a variable because if I say variable, what do you think of? You think of a formula, right? Okay, well, that means that it's a formula outcome of a population. Okay, now, what is a population? A population is the larger group. That's the larger group which you are trying to predict. All right? And what do you use to predict that? You use the sample, which is the smaller group. Okay? I may have used the Michelin example. Did I use the Michelin example with the tires with y'all? Okay. Let's say you're a quality assurance executive with Michelin, and you work, or a quality assurance engineer, whatever they call them, okay? And you work at Crystal Palace up there between Greenville and Greer, up there, between Greenville and Spartanburg. Y'all know where it is, where California Dreaming is, that exit? Okay? There's a big Crystal Palace on the left. It looks like something from the future. Well, that's the Michelin headquarters. And let's say you work there, and you're the quality assurance executive, engineer, whatever, director for the Southeast of Michelin plants. Now, I only know of 3 Michelin plants in South Carolina, and that's in Anderson, Sandy Springs, and Greenville. Okay? I don't know of any more in the Southeast, but there's probably more. But you're in charge of all of them. Okay? From Mississippi, east of the Mississippi, south of the Mason-Dixon line, or whatever. And you get paid pretty substantial for doing that, because it is a very big responsibility. And you present every year to the executive board about next year's predictions. And you got behind on work and all this, and you decided to go out to the plant, all in the Southeast. You could take about a week, and you go through all the plants, and you don't pull as many tires as you're supposed to. Okay? And you go to the meeting and you present your data, and you say, next year in 2018 or in 2019, the next year, I predict we will have a 25% defective rate. So 25% of the tires that come out of each plant will be defective in one way. Let's go with 15. All right, so the executive board says, okay, that's 25% or 15%. We need to put in 15% at $200 million, 15%. So we're going to put in $2 million in the next budget for defective tires. Does everybody understand that? Okay, so we can pay for those defective tires. Well, 2019 rolls around, or whatever year you predicted, and guess what? The defective rate that you actually measured, in that year, is 35%. Okay? You might get what? Fired. And people say, wow, it's just a mistake. No, it wasn't a mistake. You've been predicting correctly or within 5 points for the last 5 or 6 years, but you got lazy. Why'd you get lazy? Well, that happens. It's called complacent. I guess complacent. You're complacent, okay? But you did not take the work needed. You did not do the work needed with the sample. With pulling 25 tires, you should have pulled 2,000 tires, or you should have pulled 200 tires, or you should have pulled whatever the case may be. There should have been more pulled. You were lazy, you were in a hurry, and you didn't pull as many tires as you should. Okay? Remember, you're getting paid 6 figures at this Crystal Palace. You just made a mistake that probably cost them another $6 million. Okay? That don't go away. That's a pretty big chunk of change. All right? Even for Michelin. So, what I'm trying to tell you is, this stuff works. All right? But, just like everything in life, this is one of Hubert's, terms of life. I didn't create it, okay? I'm not telling you to create it. But it's one of the things that you need to live by. You get out of something what you what? Put into it. If you want to play the piano and you practice 1 day a week, you're going to suck at it. All right? If you do like this guy did or this woman did with Michelin, if you go out and half-ass it, then what? You might get written up or you might get what? Fired. Now, I know that fired and termination is words that some snowflakes don't like to hear. But it happens because, usually, because of this. Okay? And I'm not trying to preach. I'm just saying, when you're talking about taking a sample and you're talking about predicting for the future of your company, and you're talking, and this could be in the hospital. Okay? You're talking about mortality rates. Okay? Now, we don't usually we can't predict when somebody's going to die, but when you have a floor, and it's a cardio floor, like, I don't know, 2 North or whatever, and your mortality rate for the last 5 years has been 15%, and then the next year it jumps up to 60% or something like that. It's not the people coming in, it's something going on that floor. Okay, and that's why I mean it can be anywhere. If you're in a business of employment, you can use this. Now, why do we use the sample? Why don't we just go out like the population here would be Tri-County Tech students. Okay, that would be the population, and this would be like students that attend the Anderson campus. Tri-County Tech students that attend it. Why would I use the smaller group to predict for the bigger group? Why don't you just go out and survey everybody in the bigger group? Because of the 2 most important things in our lives. What is it?
Time and money.
Time and money. Good job. All right? That's why. That's why we pull 200 tires instead of doing tires at each plant. Okay? Doing all the tires at each plant. Time and money. So, statistics came about, let me ask you something. How many of you have been on a road that's 15 miles long, 5 to 15 miles long, 2 lanes, and you can't pass on it very well. And as soon as you get on that road, you get behind Little Blue-Haired Ladies Club. Okay? That set their cruise on 35 miles an hour, and they don't take their foot, they don't take it off cruise at all. All right? I don't care if there's an open stretch with no cars, 35 miles an hour. And you got Pendleton 15 at 8 o'clock, and it's like 5 till. All right? When you get to where you're going, there's a red light. You either turn right or left. I usually go into this with detail, but I don't feel like doing it this morning. Okay? But you got to turn left. Which way is she going to turn? She's going to turn left. You just predicted the future. All right? But what you have done is an example of a sample predicting the population. You have been behind that little blue-haired old lady many times, haven't you? You've been behind some other person and come up to a red light and you say, I know that guy's going to turn left because he can't drive or she can't drive. And just as soon as you say that, that blinker turns on left. Okay, that happens. You can do it with people. But what you have done, you've taken 20 million bad drivers that you've gotten behind in the past, and you've predicted what's going to happen using observations. Okay, that's what we're talking about doing. All right. So it's not just 2 maths that we have to learn to get out of college. It's not that. It's something that you use every day, but you just don't know it. Okay. So what else do we need to learn? Well, the 2 most important things with statistics, the 2 most important numbers is mean and the standard deviation. Now those 2 numbers tell you a lot, especially if you draw it in a picture. But there's other things that you need to know about. You need to know about a frequency distribution. You need to know about a data table. You need to know about Excel. You need to know about the variance. You need to know about the range. You need to know about all that good stuff. All right? That's coming. We're coming. That's what all of chapter 3 is about. And z-scores. Don't forget about those z-scores. So, what is the mean? If I was to ask you what the definition of a mean, we'd go into a loop. Okay? Some of you psychology or English people can some kind of a loop that you go through where I ask you, what is the definition of a mean? And you say, you add up everything and divide by the number. And then you say, I know, but what is that? And you say, that's the mean. I say, well, what is the mean? Then you say, it's the number all added up divided by the number, in which you just go into a loop. You never give me the definition. Now, many of you have come out of probability and statistics. So I'm going to just wait for you to tell me the definition because I know the teacher taught you the definition of the mean. So somebody give it to me. No, that's a good guess. Come on. I know all of y'all took probability and statistics, or some of you. So I'm waiting for the definition. Do you know how many people have sat through probability and statistics and have no idea what the mean is? It is the number, and write this down. It is the number where there is no variance. The number where there is no variance. The best way to show you is like this. And I always mess it up, but I'll try not to mess it up. Let's say that this is 5, 10, 15, 20, and let's say this is students in a classroom. Okay? I don't care what you call it, and I don't know, you call this, let's say this is, I don't want to use male and female because that's just two. Let's say, I'll just do classes. 15 to 19, 20 to 24, 25 to 29, and 30 to 34. And let's say that this is 5, and let's say that this is 15, and let's say that this is 25, and let's see, I'm trying not to mess this up, and this is 10. Okay, so we're going to say that there's 5, 15 to 19-year-olds, there's 20 to 24 years old, blah, 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 blah. Okay, everybody with me? All right, now, let's say that I take this little piece right here. And what this is called right here, that's called variance. We got it starts down, it goes up, or you can, it's better to do it like this. Hold on. This. Put a dot here. It goes up, then it goes up, then it goes what? Down. In other words, there's a variance. There's variance in there. It's kind of like an EKG. All right? An EKG, those things go, on the soap operas and TV shows with doctors. It goes, all right? That's variance. Okay, we don't want to talk about what the opposite of variance is, but what is the opposite of variance on the EKG? Flat line, dead. Okay, no variance. So variance is going up and down, up and down, up and down. So, let's take this piece right here. Let's see if I do this right. Let's take this piece, and let's take it, cut it off, and put it right here. I think I did this right. Okay, everybody with me? There's supposed to be one more piece. I always screw it up. All right, so that's that. And let me put another piece right here because I always screw it up. 5, and we'll call this over 34. Okay, and that's 5. And I take this piece, and I put it right here. Mathematically. Then what have I just done? I've just established the number that represents no what? Variance, and that number would be 15. That's what the average is. The average is the number that represents no variance. And I guarantee you, probably none of you that took 120 ever solved it before. I don't know why people don't teach it. Okay? That's one of the first things I did. I tried to find the definition of the mean. All right? Now, what is the definition of standard deviation? The standard deviation basically tells you how valid your data is. And we'll get into that when we start to calculate the standard deviation. All right, usually, standard deviation is how things are spread out. If it's spread out a lot, then that means your data may not be as valid as you think it is. If it's real tight, that means that your data is probably valid. And we're going to get into that with the mean, median, mode, and all that stuff. All right, so a lot of you kind of remember some of this, hopefully. Now, what about, you said something about a frequency distribution and a data table. Yep. There's two types of data in the statistics, this first section of statistics. There's a data table, and I call it data-driven. All right? Data-driven is like test grades. IQ scores. Defective tires. Ages in a classroom. All right? Those are numbers that you put from lowest to what? Highest. And you find the mean, the median, the mode, the range, and the mid-range. All of you can do the mean because you've been doing it since what, the 6th grade? Because you all want to know what your grade is at the end of the semester. Okay? So what you do is you add up all the blah, 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 and you divide and you do all that. Okay? How many of you have teachers in the past that have given the class average on a test and put it on the board? What does that tell you? That tells you you really suck at this subject, right? Or this subject area, because you made a 42 and the class average is 75. Okay? You didn't study. Now, what if everybody made a 42? And the class average would be 75. But what if everybody made a 42 in that class? Does everybody suck at that material?
No.
No. That means what? The test is not valid or the teacher sucks. Okay, so when you get you're in a classroom and here's another Hubert's list or item on Hubert's list of life. There's always one. Whether you're in class, whether you're at work, there's always one that's going to ruin it for who? For everybody. Okay? Because there's always one that's going to make 107 on a 100-point test. But let's say that you're in a chemistry class. I'm just using chemistry because it's a fairly weighted subject. And let's say the class average is 42, and pretty much everybody made a 42 to a 56, and there was nobody that made above a 60. Test is invalid. Material not presented. Material not communicated. But what if the class average is 106 and everybody made above a 90? What does that mean? That all of you are smart? Or does it mean that the test was not valid? That it was too easy? So that's what kind of things the class average, the standard deviation, all of that good stuff tells us when we're interpreting data. What other kind of data do you have? That's called a frequency distribution. A frequency distribution is nothing but a table. Okay? It's nothing but a table. A table that consists of, on the left side, classes or categories, and on the right side, head count. A qualitative distribution would be blondes, brunettes, and redheads. That's the categories with a qualitative categories and head count for 14, 2. Okay? That's the L right there, sorry. Versus a quantitative distribution, which is going to be classes and head count. 15 to 19, 4. 20 to 24, 6. 25 to 29, 8. And 30 to 34, 3. Now, your objective in this chapter, chapter 3, is to be able to find the mean and the standard deviation for both of those types of data. Now, you're not going to be able to do it with qualitative, because blonde, unless you give a number value to a blonde and a brunette and a redhead, you can't. All right? So just put an X through that blonde, brunettes, and redheads, because you can't really do a mean or a standard deviation there because you don't have any mathematical data on the left. All right. Now, a lot of people say, well, really, how do you compute with this? Well, you find the midpoint over here, and we'll get into that later. But the midpoint of 15 to 19 is what, 17? So you would use that 17 to calculate with. And that's how you do a frequency distribution, find the mean and standard deviation. You plug it through a formula, and you feel good about yourself. Okay? Now, what do we do with the mean and the standard deviation? Well, that's when it gets into your calculations. Mean, median, and the midpoint are all three numbers that are very important, that tells you about your information. Okay? I like to use the bearing analogy, the axle and bearing analogy. Some people have no clue what a bearing is, so I'm sorry, but that's the only one I can use. So I'm going to draw a bearing assembly. That's bearing housing. Bearing is right there. You've got a rod or an axle, and this, you can apply this to your car, because your car has bearings on it also. And I suck at drawing, so I really don't need any comments about my drawing. Those artists that make fun of my drawing can come up here and do the math. How about that? All right, so there's a bearing and an axle. Of course, it's more like a roller, because the bearing housings have bolts right here, and it's a flat like table right there, and there's a roll of cloth on there, whatever. Now, anytime you've got a bearing on a rod or bearing on an axle, you have a lot of RPMs going. What's RPM stand for? Revolutions per minute. So the more revolutions per minute, the more what is going to be created? Heat. All right? So a bearing, and those of you that don't know what a bearing is two metal races, and between the races is either, and this is about, about an inch and a half wide, depending on, and I don't know how to show that, but anyway, it's about an inch and a half, and inside there is either ball bearings or what we call roller bearings. And they're round, and they got a square type, and they turn, and it's lubricated with a grease, and you put grease in it. Some of them are sealed with grease, and it reduces the friction. But in order for a bearing to work, how does it fit on the axle? Does it fit loose, or does it fit tight? It fits tight. In fact, to get a bearing on an axle like this, you pretty much have to press it on with a hydraulic press, or take a BA hammer and a piece of wood and beat it onto the rod or the axle. Okay? I'm just giving you that information for a reason. I'm going somewhere with this, just bear with me. If you have that rod in there, let's color that, that's the rod right there. If it's in there and it's tight, What's this thing? When that roller or when that axle turns, what's that bearing going to do? It's going to turn, right? Because it's basically stuck on there. All right. What happens when that axle? That's too close. You can't talk again. What happens when that axle is turned up to 2,500 revolutions per minute? What does the bearing do? It goes up to 2,500 RPMs. If it's on there securely and it's on there tight, then you will have minimum what? Problems. So the key word here is tight. Versus, here's your bearing. I'm just going to do a 2D view because my 3D view sucks. And here is the axle. What's wrong with that picture? It's loose. It's on the bearing. The bearing's on there, but it's just sitting. In fact, when you turn the roller off, the axle or the rod is sitting on the bottom like this. Now, what happens when you turn the rod in this bearing? The rod turns inside the bearing, right? And what happens when you turn it up into 2,500 RPMs? Y'all ever seen the SpongeBob where they beat each other up with a bat and everything? Or a cartoon where somebody takes a bat and just beats somebody over the head with it? Well, that's what happens with that rod. That rod's going to be sitting in there going what? Going like this, and eventually it's going to beat that bearing to look something like that. This is called slop. Okay? It's also called play. Some people, you ever had play in your steering wheel? Same concept. You turn this way 2 inches and your car does nothing. Okay? You turn it 4 inches and it starts to turn. Or you take the steering wheel and you can do this and your tires do nothing. Anybody ever drove a car like that? Oh yeah, y'all never had to drive a car like that. Y'all all got brand new cars, right? No, I'm just kidding. But usually when you're driving an older car, like a 69 Camaro, and you've redone the 69 Camaro, all right, you're going to have to replace that steering box because in the 69 Camaro, you're going to have play unless somebody has replaced it. You're going to have play in the steering box because it's what? It's weird. It's wore down. There's a lot of slop in there. Okay? Think of it as baggy pants versus tight pants. All right? Okay? Tight shoes. What happens when you wear shoes, I don't want to say tight, but when you wear shoes that are good fitting shoes, do you get blisters? No. When do you get blisters? When you wear shoes that are too what? Big and they rub. All right, now where in the heck am I going with this? Well, these three numbers, if they are close, meaning 84, 82, 83, if they're close, like within 2 or 3 points of each other, that means your data is tight. Now, another word for tight in mathematics is valid. Now, what if I have 3 numbers, mean, median, and midpoint, and the mean is 47, the median is 82, and, well, it won't be 82, the median is 36, and the midpoint is 50. Then you've got outliers, you've got all kind of messed up data. So your data is sloppy. It's got a lot of play in it. It's not valid. So when you're looking at these 3 numbers, remember, if they're close together within a few points of each other, that means the data is valid. And you're going to be looking for that when you're doing your calculations on your mean, median, and mode. Okay? Everybody with me? Now, what do you do with that data after you get it? You put it here. And what is that called? It's called the bell curve. All right? Normal distribution. If 100 people fall out of the plane, 70 of them is going to fall within 2 standard deviations, or not 70, 97% is going to fall within 3 standard deviations. 95% is going to fall within 2 standard deviations. And that's just usually the law of normality. Okay? The mean goes in the middle. So I want everybody to draw this because you're going to be drawing this the rest of the semester. The mean goes in the middle. And then this is minus 1 standard deviation, minus 2 standard deviations. And out here is minus 3 standard deviations. Meaning that you're going to subtract the standard deviation from the mean, and then you're going to subtract it from this number, and then you're going to subtract it from this number. Here, you're going to add the standard deviation, just like a number line. Add 2 standard deviations, and add 3 standard deviations. Very rarely will you go outside of 3 standard deviations, because that's 98%, 99.7% of the population. And the only thing outside of 3 standard deviations is your 6-foot third graders. Or your 5-year-old that can play the 5th Beethoven on the piano. What are those called? They're called outliers. All right? Some of you may know some people like that. They can light a light bulb with their hand or whatever. Whatever the case may be. They're outside of 3 standard deviations. Most of us are where? Between 2 standard deviations. And we're considered normal. Okay, 2 standard deviations. Now, I want everybody to look up in their book, empirical rule. The empirical rule is very, very, very important. I want everybody to look it up. I don't know what page it's on, and I'm not going to go through that book right today, but the empirical rule is something that you need to remember or memorize, because it basically gives you the percentages that a lot of statistics is based on. 34%, 34%, 2.5%. I always forget this one. I think it's 13.5. 2.5% and 13.5%. Somebody check that. 13.5%. Somebody find it in your book, please. It'll be one of these, and it'll be colorful, and it'll have the percentages on it for somebody that can find it. I have no earthly idea where it is, so when you find it, just blurt it out, okay, what page it's on. Or look at the index and look empirical rule and then find it. I'm sorry, what? 132, thank you. So page 132, put it to memory because you're going to need it. Page 132. Okay, there's other things that you need to, yeah, that's it. Make sure you remember. Now, there is one thing I want to note. Some books put 2.5% past 2 standard deviations. Some books drop it down to 2.2 and then 0.3. So you need to make that note if yours, what does yours do? I'm sorry, what?
2.35.
Okay, 2.35 and then 0.15 or something? Yeah, you need to make that note. I'm old school, so I learned at 2.5, but eventually they changed this to 2.35 and then 0.15. So make that note in your notes and on your. Does either one of them show 2.5 or both of them show? Yeah, both of them show it. Okay. And read about the empirical rule. Everything about z-scores, everything about mean and standard deviation is set up around the empirical rule. Capiche? So, we've also got some other things that we're going to go into in chapter 3. Something else we're going to go into is z-scores. Z-scores are used to compare different samples. there's a question that I'm going to show you, and I do it to all my, any probability statistics and probability class that I teach. And it's Lyndon Baines Johnson's height versus Shaquille O'Neal. And we talk about relativity. Okay? What is relativity? Relativity is sitting in a probability and statistics course for 2 hours, and it feels like, what? A week. But you sit in a movie theater for 2 hours, and it feels like 30 minutes. That's relativity. Okay? Now, what in the world does that have to do with a president and a basketball player's height? Well, the question asked, it gives the heights of the presidents, and it gives the average heights of the presidents, and the height of Shaquille, of LBJ, and it gives the height of Shaquille, and it says, okay, who is relatively taller? Well, anybody with 2 teeth in their head can tell you that Shaquille is taller, but that's not what the question is asking. What is the question asking? The question is asking, who is taller in their respective populations? That's what relatively means, okay, in a statistic standpoint. Who is taller relative to their populations? And we go into the, what's the qualifications for being president?
Certain at least
certain
one
age, what
term.
is it, 42 or something? 35. Is it 35? 35, and you got to be a good, upstanding, born citizen of the United States, don't have felons and all that stuff, okay? Don't have killed anybody, all right? Can you be in a wheelchair? Yeah. We have a president in a wheelchair. Can you have a president with heart disease? Yeah, we've had a president. Can you have a 300-pound president? Yes. Taft was over 300 pounds. Shortest president was like 4'5" or something. He was, I don't know who he was. He was one of those in the early times. Okay? The whole point is, there is no requirement for being president of the United States except for those 2 things. All right? So, being a tall president would basically make you a big fish in a little pond versus a basketball player. What's one of the requirements, and it's not a requirement, you got to be able to run up and down the court, and you got to be able to play defense, and you got to be able to, well, Shaquille couldn't shoot very well, but he just stood there and dunked it or whatever, but, you got to be able to get the ball in the basket, okay? Those 3 things. Is there any requirement that says you have to be a certain height to be in the NBA? No. Spud Webb was 5'5", and he could dunk. Okay? So, and those of you who don't know who Spud Webb was, he was a basketball player. I think he came from North Carolina. I think he played with Michael Jordan, I think. But you have to look it up. I can't remember. My memory is shoddy. But the whole point is, what is height in basketball? Is it an advantage or is it a requirement? It's an advantage. If you're a 6-foot 3rd grader, what happens to you when you get to the 7th grade? Who's going to be coming around talking to you about playing basketball? The physical education coach. Okay? If you bench 325 pounds by the time you're in the 7th grade, what do you think is going to be coming to you, talking to you about playing football? The coach. All right? Why? Because those are advantages on both of those sports. So, if you are a tall basketball player, are you a big fish in a little pond or a little fish in a big pond? You're good. You're a little fish. You're with me. Good. Okay, good. Half of you daydreaming. Somebody's actually listening. All right. You're a little fish in a big pond because everybody in basketball is what? Tall. Okay? So that's what relativity is. Are you tall in your own population? And it comes out to be Lyndon Baines Johnson is taller because he's in a field where nobody, doesn't have to be tall, so he's relatively taller just by a few points. And that's what z-scores do. They tell us how to compare 2 different populations or 2 different samples. What else are we going to learn about? We're going to learn about a box plot. We're going to learn about quartiles and box plots. And that will finish chapter 3 pretty much. Okay? So, now, let me go ahead and tell you how I teach chapter 3. A lot of times I use the Excel spreadsheet. All right, now, I want everybody in here to write down, Hubert uses the Excel spreadsheet, but that does not mean I have to use it. I want you to put that in your notes, because I don't want somebody at the end of the semester, well, he makes us use the Excel spreadsheet. You ain't got to do nothing but pay taxes and die, okay? I don't make you do anything in here. The only thing I make you do is take the test, and that's just a requirement of the school. It isn't me. But I want you to write down that Hubert does not make me use Excel. Now, I'm going to show you how to do it on Excel. Why? Because that's the only way I can get all the calculations on that little board, because I write all over the place. So if I tried to write the columns and do it on the calculations with my marker or this stylus, it would take me 4 of those boards up there, and I'd have to add, and I'd have to go back and forth, and that's just not productive. So what I do is I put Excel on the board, and then we actually work the problems on Excel. Now, there's 2 people in here. There's a person that says, oh, I love Excel. I can do that. And then there's a person that says, what's Excel? I don't care which one you are. I'm doing it just to present. So I want you to write it down that I do it to present the material. Okay? Now, what about your calculator? I will let you use your calculator when the time comes, okay? So some of you on the calculator drill team in high school, you just need to take some medicine and just chill for a little bit, okay? Because I don't want you punching anything on the computer or the calculator until you see actually how it's done, because some of you don't know how it's done because you were told just to use the calculator in high school. And I don't think that teaches you anything. I can teach a monkey how to use a calculator, or my son how to use a calculator, and he's only like 11 years old. So the whole point is I want you to learn this stuff. So with that being said, let's start off with something simple like test scores. And I'll put it on the Excel spreadsheet here in just a minute. 76. I'll go ahead and put it in order for you. 78, 82, 81, 85, 90, 93. I want you to calculate everything that you know how to calculate with those numbers. Some of you, it may be just the mean. Some of you, it may be the mean and the median. Some of you might can go down the whole list of things. I just want you to predict and not use a calculator. I want you to do it by hand and tell me, and just tell yourself what you can calculate. If you can't calculate anything, don't feel pregnant. It ain't no big deal, okay? Just chill, because we're going to go through the whole thing and show you how to do everything. Because remember, I teach students that need to be taught. I don't teach the students that wrote the book or think they wrote the book. And if you can't do it after that, then you pretty much suck, a loser, and you should quit school. I'll give you the list of things that I expect. Mean, median, mode, which is really useless. Mean, median, mode, range, mid-range, and variance, and standard deviation. Now, you can only do 2 or 3 of those. That's fine. If you don't want to do any of it, that's fine too. I hate when the weather is like this, because you wear a long sleeve shirt and burn up. You wear a short sleeve shirt, everybody looks at you like crazy. You get up in the morning, there's icicles hanging off your nose, and you get up in the afternoon, that's a turn the air conditioner on. It's the Russians' fault. Okay, when I asked you what the mean is, hopefully most of you know how to get the mean because you've averaged your grades up before. So I'm going to hit auto sum and add these up. And I'm going to divide by n. Okay? Now, if you want to write down the formula for the mean, it's the summation of x over n. So you'd write a summation of x over n. That's how you find the mean. The mean is also called, give me the different names of the mean. There's 3 or 4 different names. What are they? Average. What else? X bar. And I just put X bar. I don't feel like going and pulling in the symbol. So I don't need anybody trying to teach me how to use Excel. Average, X bar. What else? Mu. The median. What is specific about the median? What do you remember in your probability and statistics about the median? What are you supposed to remember? If n is odd, pick the middle. Okay? What if n is even? You got to take the average of what? The two middles. So write that down. When n is odd, pick the middle. When n is even, you have to pick the middle too and take the average. So write that down. When n is odd, you pick the middle. When n is even, you take the two middle terms and average them. So, I'm going to take my handy dandy highlighter and I'm going to highlight those two yellow. And I'm going to go over here and I'm going to say sum those two guys and I'm going to divide it by what? 2. So everybody should get that. The mode is worthless. The homework questions ask for it and the test asks for it, and that's why I asked for it. I really don't care about it. But there's no mode here, so I put NA, none, no mode, whatever the case may be. Okay, so I'm just going to put none. You can leave it blank. Do not put 0, because there are some smart aleck teachers that will mark it wrong and say 0 is not even in their data. Okay, no life. No girlfriend, no boyfriend, that type of person, okay? No friends, sits at home all the time, you know, that type. Okay, range. Now that's pretty simple. What's your range? It's going to be your highest minus what? Okay, if you miss the range, don't tell anybody, okay? High minus low. So that's going to be equal to your highest minus what? Your lowest. And you feel good about yourself. Do not miss the range. If you do miss the range, don't tell anybody. Oh, I missed the range on that one. And instantly people hang a sign around your neck that says you need to be on medication or something. All right, mid-range. What is the mid-range? It's like the midpoint. It's equal to the average of the highest plus the what? The lowest. Now, a lot of people say, what is this? Well, in the box plot, you're going to see what this is because it's basically the midpoint of your number line. Okay, it's the midpoint of your number line. And it's very important, especially when we get to the box plots. High plus the low divided by 2. Now, when we get to the variance, I need to put the formula on the board so you can read the formula, okay? Because I like students that can read a formula, okay? I don't like students that I put the formula on the board and they go, having fun, birds. In other words, they don't even read the formula. So the formula for variance and standard deviation is the same, but you do something different for the standard deviation. But basically, they use the base of this formula. It is summation of x minus x bar raised to the second power divided by n minus 1. So you have to go through and you have to actually take the mean from each of the numbers. You have to square those numbers and then you have to add them up. And that's when you get numerator. So go ahead and do that. Draw a column besides your x numbers and title it x minus x bar. And take each one of those x's and subtract the mean, and you can use your calculator for that. Okay? Take each one of those, the first number, what is the first number? 70 what? So it'd be 76 minus 84. Make sure you make sure you put a title at the top that says x minus x bar. I'm going to go up here and I'm going to put x minus x bar equals 76 minus 84. And for those Excel people, hit F4 to lock and copy down. Oops. Okay, I'm having a hard time. Hold on. Dang old conspiracy. There we go. Now, what am I going to do to x minus x bar after I get those numbers? What are you going to do? Well, remember, please excuse my dear Aunt Sally. I did what was in parentheses first. Now I'm going to do what? Exponent. So I'm going to take x minus x bar, and what am I going to do to it? I'm going to square it. So x minus x bar, quantity squared. So equals this number raised to the second power. Okay, so let's take a highlighter, and I'm going to highlight this right here, yellow, and I'm going to highlight this yellow, because we did that. You ever tried to draw with a mouse? It really sucks. Okay, there we go. And let's see, now we're going to square it, so I'm going to change that to a, that's that right there, and we just did that right here. So in my numerator, what's the only thing that's not colored with a highlighter? Okay, the numerator is the one up top, okay? The summation. So what am I going to do to that green column right there? I thank you for the interaction. I appreciate that. I'm glad you read the cue to whoever that was to interact. Thank you. Maybe we can get 98% of the class to follow suit, to interact with the teacher. That would be nice. Oh, conditioning. So, sum of all those and enter. There is your numerator. 222 is your numerator. So now I'm going to go over to my handy dandy formula. And over here, I'm going to put equals this number divided by, okay, get your calculators out and take 6 and minus 1. What do you get? 5. Hopefully you didn't have to use a calculator for that. some of you on the calculator drill team did. 44.4 is your variance. Now, what do you need to do? Some of you that had 120 before, do you remember? What do you do to the variance to get the standard deviation? Good job. Take the square root or raise it to the 1/2 power. I do the 1/2 power because eventually your calculator, if you go into calculus or you do with these things right here, it doesn't like the square root, so it does rational exponents, so you raise it to the 1/2 power. So I take that 44 and I raise it to the 0.5 power. And there is your standard deviation. Remember, the two most important things are this guy, and we'll highlight it green or highlight it blue, and this number. Okay, now what can you do with those two numbers? Well, you can basically draw a normal distribution. Put the mean in the middle, equals this number plus this number, lock, and you can take it out as far as you want. If I could ever get the... That's 3 standard deviations to the left, I meant to the right, and over here equals this number minus standard deviation, F4, enter, and take that one and 3 to the left. So 99.7% is going to fall between 64 and 104 as far as the test grades. Okay? And that's how you do the mean and standard deviation of a data set. Question, gripe, complaint. Okay. That pretty much takes you through about 3.3. All right? But what I want you to do is I want you to go home this weekend and I want you to get chapter 1 and chapter 2 out of the way. Okay? And that way you can concentrate on chapter 3, because chapter 3 is 80% of your unit 1 test. So, get the chapter 1 and chapter 2 stuff out of the way, maybe Friday or Saturday, and then leave yourself some time Saturday or Sunday to work on chapter 3, okay? I'm not going to pass the thing around because I'm just going to put everybody here today. Y'all have a good weekend, okay? If you got any questions, come on up after class.